All right, so this is us organizing all of the different types of factoring we've done. The first thing that I have here is I have a couple like just reminders of what we're doing when we're factoring. So when we factor, when we multiply something out, we multiply our coefficients and add our exponents. That's always going to be our rule. When we factor, we divide coefficients and subtract exponents. So when we're doing any of our greatest common factors or multiplying things out, those things are going to be true. Then the last thing here is when we combine like terms, we add our coefficients, we leave our exponents alone. In addition to factoring everything today, I'm also going to show you how to check everything using multiplication, because that is something that you will always be able to do. Also, on the test, there's some problems where you can factor or multiply. It's like matching, as you could either go from one side to the other by factoring or one side or the other by multiplying. So it's good to see the connections between those. So the first strategy we learned was greatest common factor. We use this if there is a common factor between all of the terms, and what we do is we factor that greatest common factor out. So the first thing I'm going to do on this first problem is I'm going to put an imaginary 1 right here and make this 8x to the first. Then I'm going to ask myself, what can I divide 12, 16, and 8 by? And I can divide all of those by 4. So I'm going to put a 4 out front. And then I can take however many x's the one with the least has. So x to the fourth, x to the third, x to the first. I can take x to the first. So 4x to the first is going to be my greatest common factor. Now what I'm doing is I'm dividing that out or factoring that out by dividing my coefficients and subtracting my exponents. So 12 divided by 4 is 3. And then I subtract my exponents. 4 minus 1 is also 3. So I've got 3x to the third power here. Negative 16 divided by 4 is negative 4. I can subtract my exponents. 3 minus 1 is 2. So it's x squared. And then 8 divided by 4 is 2. It's positive, so it's plus. And my exponents 1 minus 1 is none. I have no x's left on that last term there. Okay. Then on all of these problems, there's going to be a box below because we are going to have you guys multiply these back out. So on this one, if I were to multiply this back out, 4 times 3 would be 12. I'm going to add my exponents. 1 plus 3 is 4. So I've got 12x to the fourth. 4 times 4 is 16. It's negative, so it's minus 16. Add my exponents. 1 plus 2 is 3. And then my last piece, 4 times 2 is 8. And then I just have my x to the first distributes on over. And then I'm going to pause and check that my original question, I factored it and then multiplied it back out. I should be back to the original. And I'm not. I made a mistake. Does anybody see where my mistake is? What is it? Yeah, so this should be 1 plus 2 should be 3 right here. I don't remember what I said. I definitely wrote it down wrong. Fix that. Everybody makes mistakes. And see, look, I was only able to find that mistake. I would have never noticed that unless someone pointed it out, which if I make mistakes, you see, you guys should point them out. Or if I checked it with my original. Okay, right now I'm going to pause my video. I'm going to give you guys like 3. Okay, so the next section we did was 5.6, which was factoring quadratics part 1. We use this method when we have 3 terms and there is not a number in front of x squared. So there's not a number here, there's not a number here, there's technically an imaginary 1. But what's different between these and 5.9 is there is a number there in 5.9. So for 5.6, we have to find two numbers that multiply to our last number, and they have to add to our middle number. So in this problem, our middle number is -1. We got an imaginary -1 there. So we need to find two numbers that add to -1, and they need to multiply to -20. Anytime we need to multiply to a negative number, we need to use one positive and one negative. So to start, we always just leave them all positive, then we'll pick which one we need to be negative. So my numbers that multiply to 20 are 1 and 20, 2 and 10, and 4 and 5. I know that I need to make one of those numbers negative, and I need to add to a negative. So if you need to add to be negative, you want to make the big ones, the more powerful ones, negative. So I'm going to make my 20, my 10, and my 5 negative. We've got a table it'll be on your review. It's on your notes. It'll be on your review as well. And then the pair of these that adds together to be -1 is 4 and -5, because 4 minus 5 is -1. Once I figure those out, how I write my answer is like this. I'm going to write x plus 4 times x minus 5. Just like we did on the last one, we are going to multiply these out to check our answer. So I'm going to take x plus 4. I'm going to put that on the left. I'm going to take x and -5 and put that on the top. And I'm going to go ahead and multiply these out. So x times x is x squared. X times -5 is -5x. Four times x is 4x. And 4 times -5 is -20. Once I've multiplied out, I need to go combine like terms. So x squared will stay by itself. These two guys will combine together. 4x minus 5x. 4 minus 5 is -1. Then I have my -20. And I stop, I pause, I double check that this and this are the same. Because what I'm doing is I'm checking my own work today. Okay, pause my video, play. Okay, next method that we learned was factoring by grouping. Factoring by grouping we use when we have 4 terms. We factor the greatest common factor out of our first 2 terms. Then we factor the greatest common factor out of our last 2 terms. And then once we get that done, we should be left with something that's matching. We write our matching guys first, and then our 2 GCFs make our other binomial. So out of 2x cubed and 6x squared, I can divide both of those by 2x squared. Because I can divide 2 and 6 by 2. And then I can divide x squared out because that 6x squared only has an x squared to give me. 2x cubed divided by 2x squared is just x. 6x squared divided by 2x squared. 6 divided by 2 is 3. And then that x squared divides completely out. For -3x minus 9, I can divide the 3 and the 9 both by 3. But since that third term is negative, and I want to leave behind a positive x, I need to divide by -3. So my GCF out of my last 2 is -3. -3x divided by -3 is positive x. -9 divided by -3 is positive 3. Then we can notice that these guys match. So I've got x plus 3. And then my other binomial comes from here and here. So 2x squared minus 3. Okay. Any questions about the factoring steps there? This squared right here, because it came from right there.
But how is it that if it has a 3?
If what has a 3?
Oh my gosh,
Oh, because this right here has a 3? Okay, so the only reason we could only take out 2x squared is because it's the greatest common factor of the first two terms. This 6x squared only had an x squared it could give me. So the biggest number we could divide 2 and 6 by was 2. But then from x to the third and x squared, I can only take out what I have from the least one. That's why I pulled out just an x squared. All right, once we get it multiplied, or once we get it factored, we can also multiply it to check it. So to check it, I would put x and 3 here. I would put 2x squared and negative 3 here. And then I can multiply. I can also put an imaginary 1 right here. 2x squared times x to the first. I can also put an imaginary 1 right there. 2 times 1 is 2. Add my exponents. 1 plus 2 is 3. So I've got 2x cubed. Then I've got 1x to the first times negative 3. That's just going to be negative 3x to the first in this top right-hand box. Bottom left-hand box, 3 times 2 is 6. So that's 6. And then x squared just comes down to be 6x squared. And then 3 times negative 3 is negative 9. Okay, for this one, when we go to write our final answer, there are no like terms we can combine. We do, however, have to write it in standard form. So that's highest, lowest exponent. So it would be 2x cubed, then 6x squared. Since it's positive, it's plus. Then negative 3x to the first, then minus 9. And we check that these two things match, which they do. Okay, I'm going to pause my recording. Hey, the next method of factoring we had was our special scenario one that we used when we had a difference, which is subtraction, of perfect squares. We use this when we have two terms that are being subtracted with perfect squares. Our rule is if we can figure out what these things are squared, it's going to be ax plus b and ax minus b. So 9x squared is 3x times 3x. 49 is 7 times 7. So really what I did there is I did the square root of 9, square root of 49. With that, my answer is literally just 3x plus 7 times 3x minus 7. So as a special rule, it only works when it's a difference, which is subtraction, and it only works for special square or for perfect squares. With that now in mind, we can multiply it out. So we've got 3x plus 7 can go on one side. And then 3x and negative 7 can go on the top. When we go to multiply those out, 3 times 3 is 9. And x times x is x squared. Top right-hand corner, 3x times negative 7 is negative 21x. I just did the 3 times negative 7. Bottom left-hand corner, 7 times 3x is 21x. And then bottom right-hand corner, 7 times negative 7 is negative 49. Once we get our boxes filled out, we can go to combine like terms. This 21x and this negative 21x, what are they going to do? What? Cancel. That's what I thought you said. So my answer on this one would just be 9x squared minus 49. Okay. I am going to give you guys 3 more minutes to work on this last one, and then we will do the last one. Hey, starting our recording again. Hey, the last section that we're going to review real quick is 5.9. 5.9 is the method that we use to factor when we have 3 terms with a number in front of x squared. We find 2 numbers that multiply together to be AC and add to B, and that should say like 5.6. I forgot to change those from last year. Then we split up our middle term using those 2 numbers, and we factor by grouping like we did in 5.7. Again, forgot to change those from last year. So make those 2 tiny edits, and then we are going to get started. So in this problem, my A value is 12. So A equals 12. My B value is negative 4. And my C value is negative 5. I need to find 2 numbers that multiply together to be AC. So they have to multiply together to be A times C, which is 12 times negative 5, which is negative 60. We use our magic X for these. And so we say in the top of our X, okay, I need to multiply to be negative 60. And the bottom, we say, okay, I need to add to me my B value, which is negative 4. So we need to find 2 numbers, multiply together to be 60, and are 4 apart, and then we'll make the bigger one be negative. So numbers that multiply together to be 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. So 6 and 10 multiply together to be 60. And in order to add those together to be negative 4, I make the 10 negative. So that's this first step, the find 2 numbers that multiply to AC and add to B. Once I figure those out, I'm going to use those to split up my middle term. So my 12x squared stays the same. But then instead of having minus 4x, I now have plus 6x minus 10x. Plus 6x minus 10x. And then I still have minus 5. Okay, once I've got that split up, from there it's smooth sailing because all I need to do is factor by grouping. So out of 12x squared and 6x, I can divide both of those by 6x. So 12x squared divided by 6x, 12 divided by 6 is 2. And then for my x's, 2 minus 1 is just 1, so I've got 2x left there. Then right here, 6x divided by 6x, anything divided by itself is 1. So we put in a placeholder 1 here. From negative 10x minus 5, I can divide negative 10 and negative 5 both by 5. And since they're both negative, I want to divide out a negative as well. So I'm going to divide by negative 5 here. Negative 10x divided by negative 5 is 2x. Negative 5 divided by negative 5 is positive 1. And then from there, these guys match. 2x plus 1 and 2x plus 1 match. And the rest of my answer is 6x and negative 5. So once I want to go multiply that out, or when I want to go multiply that out, 2x and 1 can go on the left. 6x and negative 5 can go on the top. 2x times 6x is 12x squared. 2x times negative 5 is negative 10x. One times 6x is 6x. And 1 times negative 5 is negative 5. For our final answer, we combine like terms, so these two will combine together. So 12x squared will go by itself. 6x minus 10x is negative 4x. And then my negative 5 is just minus 5. Okay, I'm going to go ahead and stop my recording one last time.